Good evening, everyone. So, welcome to JE Crash Course of Amrita. So, we are starting chemistry class now. So, we have some exciting questions today. Shall we start? Okay, fine. See, look at this question. This question is from kinetics. Okay, from kinetics, basically, what is kinetics? Kinetics is all about to study how fast a reaction is or how slow a reaction is, obviously to study rate of a reaction, speed of a reaction, whether it is slow or very fast reactions. Can anybody tell me very fast reaction example? Very fast reaction within fraction of seconds it should takes place. Can you tell me very fast reactions? What are they? Very fast, extremely fast reactions. Do you know? Extremely fast reactions, like very fast. Tritium. Okay. You ever heard free radical reactions? Free radicals? Do you know free radical means? Yes. Free radicals combination is one of the most no very fastest reaction, you can say. Okay. So this takes place in nanoseconds or like 10 power minus 12 seconds also. So very fast reactions. Like if you have a radical like this, let me show you that. If a radical X radical, this combines with X radical, so extremely fast reactions. We can say very important exceptionally fast. So activation energy approximately zero, because activation energy generally it is not zero for any reaction. There should be some energy barrier, means reactant must have some energy to get products, but in this reactions what we can take is it is almost zero. They quickly react very fast and forms products. Okay, fine. And what is very slow reaction? Do you know what is slow reaction means? Any slow reaction, very slow reaction? Extremely slow reactions. Okay, so what is that reaction? Tell me. Yes, exactly. No, rusting of iron, you can take exactly. It is very slow reaction. Now, without experiment, no, you can't say exactly how fast it is. But here, experimental data is given. Some experiment was performed, no, with these reactants, and this is experimental data. How fast this reaction is. Concentrations are given. See, first time they performed an experiment with zero point 0.1 molar A, zero point 0.1 molar B. The rate of reaction is this much, 6 into 10 power minus 3. And second time when they performed reaction, but different concentrations, now the rate is different. So like that, experimental data, the kinetic study means it is basically experimental. So experimental data is given. Now from this, we can write rate law. Okay, so listen carefully. How do we write rate law from the given information? Okay, so what are the reactants? 2A plus B gives C plus D. Okay, so 2A plus B gives C plus D. So rate law, rate I'm taking K into A power X, B power Y. So I'll take like this. Okay, so from we should calculate in a simple manner. For that, what I'm doing is, so let us take equation wise. Okay, this is equation 1, this is 2, or 1 and 2 already given, fine. So I'll observe this 1 and 4 first. 1 and 4. In 1 and 4, what I'm doing is I kept B constant. Just focus on first and fourth experiment. Okay, B kept constant, but A changed 4 times. many times rate is changed? Look at this. How many times rate is changed? Is it 4 times or not? Yes, right? So 24 into 10 power minus 2. It is 24 into 10 power minus 3. You can write, right? 24 into 10 power minus 3. That is fine. 6 into 4. 4 times rate is changed. So what I can write in a simple manner, no? B kept constant, but A is getting changed. 4 power x. Rate has changed how many times? 4 times. So x equal to 1. So x value is 1. So from experimental results, we have the order of A now. Yes or no? Okay. X equal to 1. Anybody has doubt in this? No doubts, right? See, A increased 4 times. So 4 power x I'm writing. B is constant, but rate increased 4 times. Okay. 6 into 4. Look at the values. Acha. So listen, if you have not understood, no, I'll go by other way. Rate 1 is equal to 6 into 10 power minus 3. Rate 2. So what I'm writing is 24 into 10 power minus 3. I can write this, right? Yes. Okay. Now, what I'll write, R2 by R1. R2 by R1. So that is equal to 4, right? But here, K is constant. So initially it is A. Now 4 times increased, but B is same. Okay. Second experiment is this. Fourth experiment. No, R1, R4, right? 1 second. Change this. R4. R4 by R1. Okay. R fourth experiment rate by first experiment rate. So this is equal to K into A power X, B power Y. So how much is it? So simple, right? K gets cancelled. Okay, B power Y, B power Y get cancelled. So only 4 is remaining. 4 power X. So X equal to 1. I hope everybody understood now, right? Okay. Now let's find out B also. Acha, how you are saying X equal to 1? Very simple. See, 4 power X equal to 1. Acha, 1 second. Acha. X equal to 4 power X equal to 4, no? So bases are same, right? Power should be same. 4 power X equal to 4 power 1. If bases are same, power should be 1, right? Powers are equal. Now, how do we get Y? Now, how do we get Y? Because 4 cases are given, you can take any two. Okay, any two and find. How to get Y? Where it is easy, tell me which experiments I should choose. 1 to 4. I can better use 2 and 3, right? Look at this. 2 and 3 are easy because A kept constant. We don't need to worry about X now. Only Y. 2 and 3. So now from 2 and 3, just check, no? Rate 7.2 into 10 power minus 2. So this is just 28.8. Just 4 times, right? Again, rate increase 4 times. Okay. So this is increased 2 times. B increased 2 times. Now tell me. So what is the order now? Y. Y value. You can find out, I guess, right? Very easily you can find now. What is Y value? Just look at second and third experiment. So what is the correct option now? So this from 2 and 3, let me show you this also. Okay, from 2 and 3. Y I should write, right? So how many times this B increased, B concentration 2 times increased, but this increased 4 times, right? So 2 power Y is equal to 4, Y is equal to 2. Okay, so X equal to 1, Y is equal to 2. So exactly what is the correct option? Option D. So this is how we should find out orders. So this power is called as order. Order of reaction is 1 plus 2. Sum of the powers, order is 3. Third order reaction it is. How are we finding order? Order must be from experiment. You can't say the order is 1 or 2 by looking at the equation. We must know the experimental data. Okay, if this is given, then only you can find out the rate law. From that rate law, the powers are orders. Okay, fine. Moving on to the next question now. See this. If the rate constant for a first order reaction is K, the time required for completion of 99% is given by. But what is first order reaction rate constant formula? Okay, so what is first order rate constant formula? If it is first order, listen carefully. K is equal to 2.303 by T log A by A minus X. This is first order. Okay, this is first order rate constant. Time required for completion of 99%. So here I'll explain you the term. No, K is rate constant, fine. T is time taken. What is A? A is initial concentration. Initial concentration. What is A minus X here? So it's remaining concentration. Remaining concentration. What is X means? The amount of A, the concentration of A, which is reacted. No? Concentration which is reacted. Okay, so now just substitute this, we'll get time, right? 99%. So sir, what is 99% meaning? Initial nothing is given, fine. Let us assume 100%. No, initially 100%, right? So we'll substitute this. K is equal to 2.303 by T 99%. Okay, this is logarithm 100. If 99% is reacted, completed, 1% is remaining. So T 99% is equal to 2.303 by K log 10 power 2. So T 99% is equal to, so 2.303 log 10 power X is X, no? 2.303 into 2 by log K. Look at this. Okay, any doubts here? No, right? Just look at the equation and that's it. Done. So we'll move on to the next question then. Okay, first order reaction means always. What are first order reaction example? Can you give me any example which is first order reaction? See, N2O5 decomposition is first order reaction. Okay, hydrogen peroxide decomposition is also first order reaction. So they are very common example like ester hydrolysis in presence of acid. So that is also first order reaction. Understood, right? So there are first order reaction standard examples. Okay, fine. Okay, so look at this one. Yes, nuclear reactions, very important. All radioactive reactions are first order. That is why in nuclear chemistry we only use that First order only, rate constant. Decay constant, we say that. Okay, fine. 60% of first order reaction was completed in 60 minutes. 50% of same reaction would be completed in approximately how many minutes? How do we proceed with this? So we must know for any reaction, no, K must be constant. K must be same throughout the reaction. If it is 10%, 20%, 30%, no, K must be same. Okay, by making use of this, we can find now. Okay, so 2.303 by, first I'll calculate for 60%. No, I'll write expression for 60%. So 2.303 by 60 minutes, fine. Log 60% means 100 A by, again say this, no, this is a formula, 2.303 by T log A by A minus X. Okay, so if you see this 100 by how much it is, 60% is completed, 40 is remaining. So this is equal to 2.303 by 50%. No, so how much time it has taken? Let us assume T. This is we should calculate log 100, 50% completed, 50 is remaining. So what we can do is this is getting cancelled. Correct? Fine. Next, proceed and calculate 1 by 60. Okay. Log 10 by 4. Log 10 by 4 means what you can write is log 2 5 by 2. Okay. Log 5 by 2 is equal to 1 by T log. This is 2 log 2. So can you tell me what is this now? What is the time? T value. Can we find? Sir, how do we find this? Very simple. T, you bring this side, no? T, you bring this side. This is 60 log 2 by log 5 minus log 2. We know the values. Okay. So log 2 is 0.3. We should remember, no? Log 2 is 0.3010, but you can take approximately 0.3. Log 3 approximately 0.47 you can take. Log 4 is approximately 0.6. Log 5, we should know this is 0.7. So these values are enough. Okay. If any log 17, logs 19, such values are there, those values, logarithm values, will be provided to us. Okay, so we can find out now 60 into, okay, so 60 into 0.3 by 0.7 minus 0.3. So what option we get? Look at this. How many minutes? Calculate and tell me how many minutes we'll get. Everyone getting the same answer? Option E. Exactly. Okay, fine. Good, good. So that is 45 minutes. Okay, fine. What we did here, you can calculate any X percentage of first order reaction by equalizing K value. We should get option A. Okay, done. Next question. See this. Okay. See one more interesting question here. For a reaction, activation energy equal to 0 and the rate constant at 200 Kelvin is 1.6 into 10 power 6 seconds. And look at this, no? If activation energy is less, rate constant will be more. Rate constant always will be very high. See, rate constant is 10 power 6 means it's a very, very fast reaction. Okay. E equal to 0, rate constant is given. Rate constant 400 Kelvin is how much? How do we know this? What is the relation between rate constant and temperature? So we know Arrhenius equation. Okay, Arrhenius equation. What it says? K is equal to, it gives a relation between activation energy and temperature. How they affect rate of a reaction, how they affect speed of reaction. Okay, so if we take logarithm, okay, and then what will happen is you will get an equation like this, no, logarithm, and integrate it between the limits. So log k2 by k1, okay, see this carefully, and ea by 2.303 r 1 by t1 minus 1 by t2. This is the formula we should use. In general, Arrhenius equation is k equal to a into e power minus a by rt. We integrate them between the limits k1 to k2, t1 to t2. Now activation energy is 0. How do we proceed now? See, log k2 by k1, very simple calculation. EA is 0. 0 into anything is 0. But k2 by k1 is how much? Log 1, right? K2 by k1 is 1. So k2 is equal to k1. So look at this, right? So that means even if you change temperature, no, there is no such change. Rate will not increase, rate will not decrease. Understood? Even if you change temperature, usually what happens if you change temperature, no, rate will increase or decrease. Any chemical reaction as you change temperature, so rate will definitely increase, correct? And there is one experimental value also. Every 10 degrees Celsius, no, means if for room temperature 25 degrees Celsius, right, if you increase the temperature till 35 degrees Celsius, so what will happen there? Rate will increase 2 times. Okay, for many reactions, what will happen? Every 10 degrees Celsius or 10 Kelvin change, just change it as delta T, change in temperature, rate increases 2 times for most of the reaction. You increase the temperature, rate increase 2 times. But here what is happening? Activation energy is 0. So 0 into all temperature, everything, no, or yes. So what could be the reason behind this? Yes, thermal energy increases. The molecules gain more energy. So more faster they'll attack, no? So that is why they reach, no, rate will increase more, speed will increase. And see this. Achha. The same concept again mentioned here. Temperature effect. In a zero order reaction, for every 10 degrees Celsius rise in temperature, rate is doubled. Temperature increase from 10 to 100 degrees Celsius, how many times rate will increase? Every 10 degrees Celsius, 2 times. Now 10 to 100, how many times rate will increase? Can you tell me this now? Every 10 degrees, 2 times. 0 to 100. How do you do this then? Don't use simple unitary method. It won't work. Okay. Option B. Achha, 1 second. See this. No. 10 to for every 10 degrees Celsius, right? So 10 to 20. Okay. So this is increased how many times? 2 times. Correct? Rate increase 2 times. 20 to 30. 2 to 2. 4 times, right? 2 power 2 times. Okay. So like that, if you proceed, no, very simple way I'll give you. So this is also called, no, temperature coefficient. coefficient is mu. Mu is given to. What is temperature coefficient here? Every 10 degrees Celsius rate is doubled. It is given, right? Doubled. So this is what happens with many reactions, most of the chemical reactions. Okay. So we can take mu equal to 2. So this we can use T2 minus T1 by 10. Powers it will come, right? 2 times, 2 power 2, 2 power 3, 2 power 4, like that. So final minus initial temperature by 10. So these many times rate will increase if temperatures are given. So temperature coefficient is 2. Okay. So this is 2 power T2 minus T1, 100 minus 10 by 10. So this is how much? 2 power 100 minus 10 is 90. 90 by 10, no? 9. 2 power 9 is how much? 2 power 9. Is it 5 and 12? Yes or no? Okay. You're getting the point here, right? So every time 2 powers, it will go as power 2 times, 4 times, like that. Done? Okay, great. So this is called temperature coefficient. Next question. See this? Okay. Look at this question here. Which one of the following characteristics is associated with adsorption? Okay. But what is adsorption? Do you know what is adsorption here? Adsorption theory question it is. Okay. So look at this. Adsorption. Okay. So this is basically occurs on the surface. So we can say it as surface phenomena. It is not any compound which is not going inside and only occurs on the surface. That phenomena is called adsorption. See, what are the common examples? What are the common example? If a teacher is writing on the blackboard, no, or whiteboard, whatever it is, okay, so with marker or with a chalk, piece of chalk, no, that is simple adsorption, very simple adsorption, because where that chalk is not going inside to the board, or marker is not going inside, only on the surface, right? And in this winter season, early morning, no, what happens? There are water drops on the plants, leaves, plant leaves, basically. So that leaf surface is holding that water molecule. So that is on the surface only. Okay. So there are many examples of, yes, dust and duster. Very good. Okay. Or dust and table. Dust particles are attracted by table, sofa, whatever it is, right? So that process occurs only on the surface. That is adsorption. In this class 12th, you know, this chapter, what you will learn is, so there is solid gas. Most of the cases, no, we observe this, we discuss in detail solid gas adsorption. Solid surface, this is called adsorbent. The surface on which adsorption is taking place, that material is called, no, adsorbent. And the gas which is adsorbed, no, so that is adsorbate. This is most common. Okay, solid gas system adsorption will be discussed in surface chemistry. Okay. Yes. Now see this. What is happening in adsorption? Adsorption is spontaneous process. Any type of adsorption, no need to provide any energy for this. This is just a spontaneous. Spontaneous meaning, again, I'm reminding you, it doesn't mean it is very fast. Spontaneous doesn't mean fast in chemistry. Spontaneous reply, we say that, okay na? So no, not instantaneous. Spontaneous means it proceeds in a single direction. Very important. Spontaneous in chemistry means it is not instantaneous. Spontaneous is different from instantaneous. Spontaneous means it proceeds in a single direction. So this is spontaneous. This process will take place. But you can't say adsorption is very spontaneous. No. It is not like that. Adsorption is not instantaneous, it is spontaneous. Delta G is negative for this. Okay. And on a solid surface, no, on a solid surface, if gas molecules are attracted, gas molecules are present, means there are attractions, right? That is why on the surface these dust particles get trapped, gas molecules get trapped, right? So what is happening here? Attractions are there. So delta H for attractions, delta H is negative, means energy is released because bonds are formed, attractions are formed, right? Bond breaking requires energy. Now bond formation here, so that definitely require in that gives energy out. So delta G negative and delta H is how much? Negative or positive? Delta H is also negative. What about delta S entropy? Now gas molecules, no, they are trapped. They are not moving randomly now. Yes. Now when they are attracted on the surface, they get trapped. No, they are not moving anywhere. So what happens here? Delta S is also negative. Okay. So all are negative. One of the very important process it is. Okay. Adsorption, delta G negative, delta H negative. What is the relation between delta G, delta H, delta S? Delta G is equal to delta H minus T delta S. Okay, fine. This theory question we finished. Now tell me this. No? Which one of the following statement is not correct? Please read the statements. Okay. Please read the statements. Which one of the following statement is not correct? Value of equilibrium constant is changed in presence of catalyst. Enzyme catalyst mainly biochemical reactions. Not correct, which is not correct. Okay. Coenzymes increases catalytic activity of enzyme. Catalyst does not initiate any reaction, which is not correct here. A is not correct. See, I'll show you this one. Let us say this is a reaction. Energy versus, usually what we do is we plot the reaction like energy versus reaction progress. These are called energy profile diagrams. Now, if I use a catalyst, what will happen is it moves faster, right? How it moves faster? So this part, no, this energy is activation energy from this reactant to product. This energy is EA. EA. But this will decrease. That means now activation energy decreased. Okay, so this is with catalyst and this one is without catalyst. And see, look at this, no, the energy of product is not changed, energy of reactant is not changed. Okay, if positive catalyst, exactly, no, if it is a positive catalyst, yes, that will decrease the activation energy. And look at this, no? This is basically delta H, and see this difference, reactant energy, product energy minus reactant energy, delta H. There is no effect of delta H. Delta G doesn't change, delta H doesn't change, no change. If you use catalyst, no Gibbs energy, no enthalpy will be changed. So equilibrium constant doesn't change, right? Because we know delta G is equal to minus RT ln K. No increase in amount of product. Enzyme catalyze mainly biochemical reactions. Yes, it is correct. Coenzymes. Coenzymes are like activators. Catalysts never initiate reaction. After initiating reactions, we add this. It will never start a reaction. Okay, so only incorrect statement is A. Okay, so next question, see this. Which mixture of the solution will lead to formation of negatively charged colloidal soles? So what is the meaning of this? Negatively charged colloidal soles. All colloids, no, colloids are charged. Okay, either positive, no, they can be positive, they can be negative. See, you can see many applications here, because if they don't have charge, no, what will happen? Suppose plus, 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 plus. If they're charged, no, they can't come very close. They always move randomly. That is called Brownian motion. Okay, but if they don't have charge, what will happen? The aggregation will take place without charge. No, they come closer. Okay, so without charge they come closer, but with charge they can't come closer. See, our blood is a colloid. Okay, now the colloid charge comes with many factors here, because blood contains hemoglobin. Okay, and there are many others, no, but see, blood is a charged. Yes, it is charged. Okay, now blood coagulation, suppose there is some cut, okay, some injury, what will happen? So that bleeding, how do we stop that bleeding? That must be coagulated, right? So we apply alums to stop bleedings by minor cuts or injuries, so what we apply here, we apply alums. So alums, what they do, alums are basically, they are double salts, they contain charge, right? So this two, if it is plus, this minus will combine, and now coagulation will take place. We can stop bleeding. Okay, blood positively charged, alums, they produce negative, or blood negatively charged, so this positive negative will combine and forms coagulation. So that's how we can stop, the bleeding from minor injuries. Okay, so they apply that alum, or you can see the application here also in like most beautiful city, Dubai. Okay, do you know how rains or precipitation happens in Dubai? Rain, basically we say that, no, in scientific words precipitation, in normally we use raining, right? How precipitation takes place? Artificial rain. You ever, I think you heard of this artificial rain concept. Mainly, in Dubai they use artificial rains. Do you know? Yes. Okay, so what happens there is, see, look, this is also application of colloids, application of charge. Okay, see, look at this. So clouds are colloids. Okay, clouds are colloids. So how they're colloids? Because so much gas is like dispersion medium, and that trap, no, liquid particles. Okay, gas traps liquid particles, so they can be either positive or negative. You can't say the particular cloud is positive only or negative only. They can be positive, they can be negative. So in Dubai, like countries, what they do is they get very less precipitation per annum, right? Yearly, the precipitation is very low. So what they'll do, they need the rain, right? For survival, definitely rain is required. So with aeroplanes, what they'll do, they spray sand, but sand is electrolyzed. So on sand particles, what they do is, they induce charge. By electricity, they induce charge and they'll take away that sand with aeroplanes and they'll spray this sand on these clouds. Now, if clouds are positive, they interact with negative sand particles. Now, coagulation takes place. Now, precipitation starts. That is our artificial rain. That is a concept of artificial rain. I hope everybody understood, right? So basically what we should understand, colloids are charged. That's why they're able to survive. That's why they're stable. Okay. Now look at this. We are getting a colloid, but we should know where negatively charged colloid is formed. How do we know negatively charged? So where negative charge is extra. But how do we know that? See the reaction here. AgNO3 plus Ki. This is AgI plus KNO3. Okay. Now AgI is precipitate, fine, right? But on AgI particles, if there is excess I minus, no, because AgI can absorb common ion. What is common ion here? AgI contains two types of ions, right? One is positive Ag plus, one is negative I minus. See, it can either absorb any of these ions, Ag plus or I minus, but depends on the amount we are providing. See, amounts are provided, right? So what we should know? We should know where I minus is extra. If I minus is extra, yes, we get negatively charged colloid. If Ag plus is extra, then we get positively charged colloid. Okay, so now one by one options will check. I minus is coming from obviously Ki, where Ki is excess. In that cases, we get negatively charged colloid. So option 1, first option, 50 into 0.15, right? 5 millimoles. So this is 50 into 0.15. So this will not form any colloid here. This will just form precipitate. There is no charge, no? There is no extra. And see here, sorry, 50 into 1, we have 50. Okay, 50 into 1.5. Yes, this is more, right? 50 into 1.5. This is just 50. So option B. But next option you see, 50 into 1. 50 into 1, 50 into 2. This is also extra, right? 60. So there are two options, negatively charged colloids. Yes, 50 into 2, this is 100. Okay, but this is how much? 50 into 1.5. This is not 100, right? So B, C, both are correct here. Both should be correct, right? 50 into 1, 50 into 1.5, 50 into 2. Yes. B and C, in both cases, right? B and C, both cases, we get negatively charged colloid. But in option A, no colloid formation, but here what we get here, positively charged colloid, but in these two cases, negatively charged colloid, because Ki is extra. Okay, understood? We just need to see the electrolytes. If it is negative one is extra, yes, negatively charged colloid. Positive is extra, positively charged colloid. Done? Okay, fine. We'll move on to the next question then. See, look at this one. Coagulation values in millimoles per liter of electrolyte used for coagulation of As to S3 are given below. So what is coagulation power? Acha. See this, there might be some error, no? Maybe this values. Okay, that is why we are getting two options, but we get, no, this is single option correct only. Okay, so there might be some printing error, something like that. This is single option correct. But in the given values, if you compare, no, so there is no doubt B and C, both are our answers. Okay, don't worry. If in mains or in any exam, if this question comes, no, B and C both should be the answers. Okay, fine. So look at this. Coagulation values in millimoles per liter. What is coagulation value? Do you know what is coagulation value? Coagulation value means, see, listen carefully, millimoles of electrolyte which can cause coagulation precipitation, same. Okay, which can cause coagulation means aggregation of particles. If they lose charge, they'll come closer and form aggregates. Okay, so that is called coagulation. Millimoles of electrolyte which can cause coagulation of 1 liter of colloid, means how many millimoles you are adding per liter, no? So that is coagulation value. Understood, right? Now this coagulation value inversely related to power. So what I'm saying is coagulation value always, it is inversely related to its power. If the power is more, coagulation value is less. So let us imagine in a class, no, in a class there are two different students, A and B. A has extremely strong memorizing power. A is very brilliant, suppose, no, A is very brilliant and is more grasping power. If we just read one line, no, he cannot forget. Okay, but same B is somewhat like he can't remember things easily. He has to recall, he has to revise 10 times, then only he can remember. Okay, so listen carefully now. A has more power. A has more power. B has less power. Concentration, you can say. Okay, A has more focus or some God gifted power, no? But B has very less. Okay, now if 10 papers are given, okay, if 10 papers are given, we asked both the students to buy hard these 10 papers. So who will take less time now? Obviously A. Okay, because A has more power, right? He take less time. Yes or no? There are some students, who are really like God gifted. If you see, this time I have gone through the interview of NEET topper. No? So what he did, he said, no, one statement. It was what he said is he used to watch all the web series in Netflix for 4 hours daily. Okay, but he's a NEET topper. Last time NEET topper, he said this. No? He covered all the web series in Netflix. See, but he has more focus. But the rest of the time, no, he never thought about web series again. His focus was only on studies after watching that web series. Okay, so there are some God gifted students, who have very like more strong power. So A has more power means definitely A will take less time. So see, there's no coagulation power is more, so coagulation value is less. That means even if you add very less amount, so coagulation will takes place. So now tell me, what is the correct one? Correct coagulation power? (52, 0.69, 0.22). Correct order of coagulation power. Less power, more value. More value, less power. So more value is 52, you can see, right? It should be least power, right? So only one correct option I can see, correct? So this one, option C, correct? Yes, there are some God gifted students, but for everyone it is not possible, right? Only few are there. No? They have more power, concentration power, like that. But they are exceptional. They do exist, but the percentage of them is very, very less. But see, by considering that we can't watch, no, if we watch then we'll think like, if we watch for 2 hours, no, web series, we'll think about that web series all the time. So it is not possible with us, no? There are some exceptional students. Okay, right. Okay, students, now we are ending the session for today, so we'll meet in the next session. Okay, I hope you have learned new concepts today, definitely, right? Yes. Thank you, everyone. So we'll meet in one more session. Okay. Thank you. And please share your feedback.